I guess we can start, right? Okay. Some people will come later anyways. You always can miss the first minutes of presentations and it will be okay. Thanks for coming to my talk. My name is Anton. I'm a developer advocate at JetBrains. I work in Kotlin team. Today I'm going to speak about building DSLs, domain specific languages with Kotlin. I'm curious to know why you are interested in this topic. But let's do a quick show of hands. How many of you are Kotlin developers? How many of you are Java developers? How many of you are PHP developers? That's okay. Anyways, Kotlin is kind of a better Java, right? It was created as a better Java, but it turned out to be a very different language at the end, at least today. If you start using all kind of interesting features in Kotlin, it doesn't feel like Java anymore. And DSLs is not a language feature, but a combination where a lot of different language features are used. And therefore, I like to speak about DSLs because it allows you to learn about the language, individual language features and how they compose together. And this is what we are going to see today. So I talk to people a lot, and like the obvious question for me is why are they selecting Kotlin for their development? And one of the most important features that they mention is null safety. We're not going to talk about null safety today at all, but this is like the single most important language feature that Kotlin offers for many people. And then a lot of them mention coroutines, which is a feature for asynchronous programming backed by the compiler and actually the implementation inside a library. And then many of them mention multi-platform projects that you can target multiple platforms like Android, iOS, web, desktop, server-side, and so on with the single code base, or at least reused partially. And syntax. And syntax is a very emotional thingy for the developers. They just say, oh, I like the syntax, and therefore I like the language. But this is where we come to the DSLs, and we'll see that a lot of small features are really well composed together in this, let's say, notion. I don't want to say languages, because actually we will not create a new language. We will just use the language idiomatically. What are the domain-specific languages? If we talk about domain-specific as a thing, it means that it's tailored for a specific task, right? We can choose a domain area and tailor our language for the use in a specific domain or context. So a little bit of theory. There are external domain-specific languages and internal ones as well. For the external ones, you gotta build your own parser, compiler, code generator, maybe tooling support, and so on. It's a full-fledged language development with some additional computer science. And with for those today, if you need to build an external DSL, usually you would use some sort of a workbench like meta-programming system, which we also have as an IDE. And there is basically, you see IntelliJ IDEA's editor, but the editor is not actually a text editor. It's a so-called projectional editor where you have like forms and you are constrained to the values that you enter in those cells in the editor, so you cannot make a mistake. So the whole point of those domain-specific languages is constraining the domain so that the user of the language inside that domain cannot make a mistake. It's especially critical in some embedded development, maybe financial applications, and so on. The internal DSLs are constrained, or let's say they can do as much as the host language can do, and in our case it will be Kotlin. You can build DSLs in any language. It's just the expressiveness of the host language that gives you those abilities, how good the DSL will be and how expressive it will be. So in the documentation, we actually have it called type-safe builders. There is a single mention of the DSL keyword in here, but as a language feature or as a whole concept, we talk about them as type-safe builders instead. Yeah. So I give you a few examples of the DSLs in Kotlin. Usually they are provided by the libraries. So library makers make DSLs, not the application developers. And here's a simple DSL for working with databases provided by Exposed library in Kotlin. So you can describe a table, and within some transactional code, you can create a table, query the table, insert values, and so on. You can probably spot something interesting about this code, but let's see what other examples we have. For instance, a Kotlin DSL for configuring TeamCity DCI server. You can create a project, declare that some version control system is attached to that project, declare a build configuration, give it an ID, name, define some rules, dependencies, build steps, and so on. Ktor is a framework, or rather I would say a toolkit that in combination with Kotlin Next HTML library can build the DSLs for routing and responses for to the clients, right, to build structured documents. And those are the two DSLs within the same file. Well, why is that possible? Because it's not, they are not the different languages, it's just the same language, but two different libraries providing their own APIs, so that you can mix them within the same source file without problems. Spring Framework actually comes with a lot of extensions, and in the documentation you will find the links to those extensions for Kotlin, and it's a good portion of them. But the good part is that you can find the examples in the documentation as well. And well, if we analyze those different examples that I just showed you, they are very similar. Similar in a way, of course, they use Kotlin, but they also similar by the structure. And the structure is normally something that you have an entry point. Normally, it would be some kind of create verb, so that create client, create application, create route, something else. And then within that block, we have another entry point and another entry point or assignment to a property. Maybe a block could be assigned to a property, and then we can actually have some language-specific constraints in there, or even create new classes and values, and it will all be syntax colored in your IDE. Looks like magic, but it's just a idiomatic Kotlin code. And whenever you see this kind of nested structure, basically means that the library is using those language features that Kotlin provides for type-safe builders or DSLs. So for the rest of the talk, I'm going to code you a little example where we will see those individual language features step by step and see how they converge in the type-safe builder. So I have an example here. It's a simple project, and I have an example in Java which uses builders. Basically, the client builder, just setters and getters, Twitter builder, setters and getters, and so on. Very simple code, nothing is wrong with that. It's just like very linear, I would say. And there are some sections. It just builds an instance of a client with a few fields, right? What we are going to do now is to transform this Java code in Kotlin and see how we progress with this transformation and see how the structure appears that we have seen in those examples before. I'm going to just paste this Java code, and it's automatically transformed into Kotlin. Like, it's a quick transformation, not a full transformation. So what happened here, first of all, I hope everybody can see. I can zoom in if needed. Just raise the hand if you cannot see it. So there, we changed the type declaration, right? So we don't have the types on the left anymore. We have just val and then the variable name. We can put the type declaration after this, but it's not required. New keyword is gone. Semicolons are gone. They are optional. And then, well, the setters are not transformed automatically, but normally you would get something like this, property access syntax instead of setters and getters. But underneath, the setters and getters are called actually, so if I just look it up, it actually is a setter call. Then at the very end, we better transform it into string templates. So this will be like the first round of transformation. As you can see, well, not much is changing. Let's check how the code executes, and you'll see that the client instance is printed without pretty print. It's basically printing the object instance because the client class doesn't have a toString method. So assume now that the Java code that I'm using is immutable for me as a user. It is packaged in some jar file, so I cannot change it. And in this case, what would I do? I would probably create some kind of a utility method to pretty print my client object. In Java, we would normally use some string or client util class with a static method for that. In Kotlin, we're gonna do something like an extension function, and the extension function could be, I don't know, 2s, for instance, and it's gonna return a string. Let me do it like this. It's gonna return a string and return, let's say, a Twitter handle plus the company name. Company name, like this. And now if I run, I actually have to use this as well, 2s. And now if I execute the program, the client instance is pretty printed, right? So how does it work? We have an extension function that is declared on the existing class type. And this is a very dramatic feature in Kotlin. We can have extension functions, we can have extension properties, something like this. In fact, since it's a single expression function and we can turn it into a slightly shorter version of the same code, we can use the type inference for this function. But we can turn it into a property as well. So it's not a function anymore. We don't need braces. We just declare that this property is going to be a string, and it's going to have a getter like this. So that's another way of doing pretty much the same thing, and it will be working the same way, right? What is important here is that inside the extension function body, or like in the getter, in this case, the Twitter field is actually the Twitter field of the client class. So if we look it up, we can see it's a getter from the Java. So this receiver, in our case, in this specific location, means that it's a this of client instance. That's important, and let's keep it in mind for now. So we introduced this little block, or we now know about the feature in Kotlin, but we didn't move on with the transformation of our code into the block-based style. What could we do here is, again, we need an entry point to turn it into a structure. And the entry point is normally something like create client, for instance, in our case. So let's move the client instance up. and say that it's going to be created by a function, create client. And that function, let's actually start typing that. Function, create client. It's going to return an instance of a client, but it needs to take a parameter, and it's going to take a parameter as a block of code, and a block of code that takes a builder as a parameter and does this thing, like it will invoke the builder, and hello, and in Java, what is the block of code? Basically a lambda or a functional interface that takes a parameter but returns nothing, because it will just use the builder, mutate it, and call the build function, and out of that build function we're going to get an instance of a client. So in Java it's a consumer. And consumer. We can use Java types in here, no problem. And it's going to be parameterized with a client builder instance, right? So to use that now, we need an instance of that client builder. And then the block of code, or actually, yeah, the consumer, the block of code, is going to accept that instance. And after the mutation, we're going to just return the result of the build method. Cool. So now we can use this method to create the instance. And since it's a single lambda parameter, we can write that outside of the parentheses for the parameters list. So currently, what is going on there is that the builder is an implicit variable, builder, sorry, yeah, let's actually move the code first. So the whole structure that we have here, the whole code, we can actually move inside here. And this builder parameter is actually matching the parameter of the accept method at this time. And everything else is unchanged, right? So if we run this code again, we get pretty much the same result. But we already have the first level of nesting in our DSL, soon to be DSL. In lambdas can be declared as like either without the parameter, or there is an implicit name for this parameter called it. So if we just rename that and remove it from here, it is getting even more concise in this case. So conciseness, along with the safety, because type safety actually helps writing those DSLs. And conciseness is important because when your users are using the DSLs, it needs to be nice and it needs to be readable, it needs to be clean. Otherwise, the whole idea of getting this clean structure without conciseness is pretty much meaningless. What else can we do here that could be even better? In this case, we are almost like done with our transformation, but the it variable is kind of getting in a way, right? It would be nicer to be able to write the fields directly or assign the properties directly, but we cannot do that at the moment because in our case, the explicit or the implicit variable of the client builder is named it. In order to omit those its, we need to make the client builder in this context to be an implicit this receiver, so that it would be this. Of course, it's implicit, we don't have to type it out. But how do we do that? For this, we need to do a little transformation with our function here. So because we have lambdas, first of all, like we actually don't need to use the Java interfaces for that because, well, since we have lambdas, we can specify the same signature, but in native Kotlin syntax. So now it's the lambda that takes a client builder as a parameter and returns nothing. We don't need to call the accept method because it's a function node type. It can already be called as a function, and then we use builder as a parameter. So we still have the same code as an equivalent, but without the Java type. And now to make this interesting trick work, to remove the it variable, but turn it into a this implicit receiver, we can specify our lambda as an extension, because lambda is actually a function. And we have extension functions, we have extension properties, and we can have lambdas as extensions. And in the documentation, you will find them mentioned as functional literals with receivers. So we don't change the code here, but if we go up again, we can see that the properties are now assigned, and this implicit receiver is right there. So whatever is happening within the scope of this block is actually happening within the context of the client builder, not within the context of just a lambda. So this is what we wanted to get, right? The cleanest it could be. Like, there is no shorter version of that. Now, if you followed closely and you understand what I was talking about, then how do we create a Twitter build or Twitter block for this DSL? It could be something like this, all right? But we don't have the Twitter block yet. And what should it be? It should be a function, right? The function that takes a block of code, and that block of code is executed in the context of a Twitter builder now. And the Twitter function should be an extension to a client builder class. So now we create the extension, client builder, Twitter, and we need a block of code. That's going to be a Twitter builder. And we need to assign to a field of the client builder, which is going to be a Twitter. And for that, we need a Twitter builder instance, and we need to apply the block of code within the context of the Twitter builder, as you can see. And the apply function is a standard library function that can be used on any type, and it's actually an inline function. So if we go and check out the definition, what it does, it just applies a block of code on any type, and it's an inline function, so it's executed in place. That's it. So what will happen, we're gonna mutate whatever, it will execute the statements inside that block within the context of the Twitter builder, because we said so, like we declare it this way. And now, as you can see, it's a complete block of code. We can do the same trick for the company. Let's do that. So it's going to be a company function. Oh, sorry. It's going to be a company function. It's going to take a block of code that is going to be executed within the context of company builder. It's going to assign to a company field, and of course we need a company builder instance to do this. So now we have this function, and all is left here on this in this code is to move our statements inside the block and get rid of this variable that doesn't exist anymore. Right? So you get the idea. So finally, what's going on? So we get this interesting structure that looks pretty clean, and And we can compare with the initial code that we had in Java. So let me do that. As you can see, well, by the lines, by the number of lines that we have here, it's not much shorter. We didn't really win any lines of code here. We did win some characters, of course, but we also introduced some extra complexity in the form of those functions. But on the call side, like on the use side of those functions, the code looks what? It looks structured. So it's very easy for an eye to follow the structure and quickly understand what is going on there, but at the cost of the extra complexity. So the outcome or the conclusion that we can make here is that it's good, but only if you can reuse that. And therefore, it's a good feature for the libraries. If you have to, like, maybe not only for the libraries, maybe if you have to reuse this code in your project once again and once again and once again, then it's a good thing. But if you have to do that once or twice only, maybe it's not like a reason to introduce this extra complexity in the form of those extension functions into your project. But anyways, what else can we do here? So a good person should have a birthday, right? And there is a birthday field, date of birthday, which is a local date actually. So it's a local date, which is a Java implementation, of course. And if we need to assign that, if we need to assign a value to that, it's going to be something like this, right? We now have a beautiful DSL structure with some ugly invocation of Java API in here, because it doesn't fit here. It doesn't look nice. Instead, it could be something like 24th of March 2000. And this is perfectly valid code in Kotlin because we have Infix functions that can actually be used without adding the braces and the dots for invocation. How is it defined? It's an extension function, but it's an infix function that just does the same thing. LD is in my case, sorry, LD is a type alias. So it's a local date. Just wanted to make it shorter. And then we can omit the dot and the braces, and the DSL looks nice, but there is a little problem. What if we use that function outside of the block of code? And it perfectly compiles because we just added the extension function to a global type. There is no restriction where this function should be visible. We just declared it on an integer. Integer is available everywhere. And this is something that might be just not nice because you're polluting a global namespace. This is a clear indication that we need some sort of a control for this function to, for the visibility of this function that we add globally. And this is something that Kotlin is working on. So Kotlin has been evolving, and like last year we released a version of 2.0 with a new compiler that allowed us for the new development of the new language features. And now, like actually a year ago, we announced a few language features that are in the works. And on Monday there will be a beta build of 2.2 with another useful language feature that will allow constraining these kind of functions to a specific scope, especially if you are providing it as a library. So currently, if I'm using this, function, I'm giving away the internals. If I want to migrate to a new version of the date and time library, the users will have to care. But in ideal case, I want to avoid that. So I cannot show the language feature right now live, and because the build will be ready on Monday, but I will show it on the slides. So let me explain again. So we have this situation that the March function is available both inside the block and outside the block. What we want to do is to constrain it to be visible only inside the block, only in the context of the DSL that we just created. And the feature that will allow for that is called context parameters, and it's going to be experimental in 2.2. We'll see how it works out. We always take a casual approach when bringing new features. We want the users to test them first. And then the idea is that the function that we just created is going to have a context requirement. And the context requirement is imposed by your library. You're going to say that to use that function, you're going to need some sort of a date context. And that date context can be just an object within the library that you're building. And then our DSL function that was creating those instances of clients would look the same way, but the block of code that is used as a parameter would have another annotation called context requirement, basically. So we say, in order to execute this block of code, this lambda, we need to run this lambda within the context of that context object. And in Kotlin, you can specify the context really easily with a with function, and it's hidden from the client, or from the users of your library right now. So it's a library code. It's happening within the library code. To the user, it will look exactly the same way as previously, with a difference that now, since the March function is used outside of the DSL block, there is no date context, then this function is not available, not visible, and it will be a compilation error. So the new language features that we are working on in Kotlin are all mostly targeted either into making the code more concise and more user-friendly, or improving the compilation guarantees, or especially giving the tools for library authors so that you can create libraries that are very safe to use. If you had to remember one thing from this talk, this is the most important one, right? We have extension functions, we have lambdas with receivers, we have the ability to write the lambdas outside of the parentheses so that it looks like a native block of code. But the language feature that enables it all and is in the center of the DSLs as a feature in Kotlin is the ability to add or specify lambdas with receivers, like when you build this kind of DSLs. This is all. This is what I wanted to talk about today. And if you need my slides, I have them on speaker deck. The same code that I was showing in the IDE is in my GitHub. If you need to ask me something, my DMs on Twitter are open. And we have a great Kotlin channel with all the information about the language and the passionate Slack community in the Slack. So join there. And thank you very much for coming. And if you have questions, I take them now, yes.
There are also other ways to restrict these ads. Like right now, you would be able to call Twitter in Twitter. And I know there are annotations to restrict also the scope in a different way.
You mean interleaving the blocks, the receiver within the block? That's a DSL annotation. DSL marker annotation, yes, that's for a little bit different thing. Like you cannot use that annotation to restrict the extension function to be used from within a specific block of code, or require something from the user to be there, right? So currently, in my example, like when we had a block of code, like the Twitter block and the company block, and if I would move the statements between those blocks, in my example, it would work accidentally because it's how the model is working, right? But to prevent that, you would use the DSL marker annotation on the classes that are involved into the DSL. In my example, it wouldn't work because the Java classes, I made the assumption that I cannot change the Java classes, but I can extend them. I can derive from them and then annotate my new classes, and in this case, it would work. Yeah. DSL marker has some other interesting capabilities that are not documented, but not in the language, rather in the ID. Any more questions? No? Yeah.
Wouldn't you also add the function inside of the scope? The function that creates the march inside of the scope of the lambda function that will do, I guess, the same job?
I'm not sure I understood the question.
The function that allows you to create local date within more beautiful way, just add it inside of a lambda function.
That's another way of doing it. It would be like I would create another DSL, basically a date DSL to create those dates, and I would put that it not maybe in a top level, but rather within some type. So I would be like date DSL class, and I would have those functions in there. That's another way of doing it. But I have not seen a good DSL, date DSL made yet for Kotlin. Yeah. Okay, good, yeah.
First of all, thank you for the presentation. I have a more general question.
Sure.
DSL. Is it always okay to create a DSL in Kotlin, or it is a good practice to create it in some cases?
Normally, as I said, you would create it as a library. And you should not you should not think of it as a DSL. You should think of it as an API, because this is the way you're going to evolve it as well. Those are just functions. You're not creating a new grammar, code generation, or anything like that. It's just a function, and the only thing that makes it look like a DSL or a new language is the naming of the functions, and of course the lambda with the receiver that is used for a parameter of that function. That's it. If you look at how the libraries are designed in Kotlin, many of them are using this function, using those features, and this is just the style, and I wouldn't say that it's preferred or not preferred. It's the language style, and this is what normally Kotlin developers are converging to. Yeah, sure.
Yeah, is it going in some cases with the nesting code to be like a callback there or a nesting there? Is it if you have in our example client builder, a Twitter, inside of it something else?
Well, I think it could be a trade-off indeed. But the structure with nesting actually represents the real structure of the object graph that you're creating. It's not the same as callback hell, because in callback hell, you specify the behavior. Yes, with this kind of DSLs, you can also specify the behavior, but first and foremost, you're actually specifying the structure. That's why it's called type-safe builders, not the languages, yes. All right, thank you very much for coming, and thank you for all the questions. If you have questions later, you can reach out to me on Twitter anytime.